Hello, ladies and gentlemen. My name is Julie Wright, and I am the coordinator of the Waterloo Global Science Initiative. It's my pleasure to welcome you here to this Theatre of Ideas at the Perimeter Institute for Theoretical Physics in Waterloo, Ontario, Canada. This is the third and last of our public lectures that have taken place this week as part of the Equinox Summit Energy 2030. Before we begin, a few brief announcements. This lecture will run approximately 1 hour and will be followed by a question and answer session. And now is an excellent time to turn off any mobile devices that you may have with you. We just don't want to have that interruption during our talk. And this event is being streamed live and will be recorded for future broadcast. WGSI would like to acknowledge TVO, our presenting media partner, for their efforts in bringing this programming to you online and on TV. If you've missed any of the lectures this week, you can watch video on demand at wgsi.org. And our closing plenary will stream live tomorrow afternoon at 2 p.m. Today's Equinox Summit public lecture features Dr. David Keith, who will talk to us about technology, energy, and nature with a specific focus on our human values and choices. David Keith holds the Canada Research Chair in Energy and the Environment. He's a professor at the University of Calgary and adjunct professor at Carnegie Mellon University. He's an advisor to Bill Gates on climate and energy. He is one of Time Magazine's Heroes of the Environment in 2009. And since 2009, he has been leading Carbon Engineering, a startup company developing technology to capture CO2 out of the air. And now it's my pleasure to introduce Dr. David Keith.
Thank you. Thanks a lot. Thank you. It's a real pleasure to be here. Well, today I'm going to try a new talk with new ideas, and hopefully I won't stumble too big. I'm going to tackle some of the biggest questions that we have, sort of fundamental question that concerns me personally, and I'll make this talk really deeply personal because I don't know any other way to do it. The question at root really is, what are the reasons that we have for preserving the natural world? So one possibility is that we are near the very limits of global carrying capacity. We're close to some tipping point, some catastrophic tipping point, and so we are forced out of necessity to rethink, reshape our relationship with the natural world, otherwise we'll go extinct. Another possibility is that technology has given us so much maneuvering room through our wealth, through the leverage that technology has given us, that in fact we could easily figure out how to live on this planet with 2 or 3 times as many people as we do now and still enable the poorest billions to grow richer. If it's the former, then we have a forced choice. Morals don't enter it. If it's the latter, then we have to really rethink in some fundamental ways what our relationship to nature is in this world in which we are so powerful, how we conceive it, how we want it to be in the future, but it's a choice. I will basically argue for the latter view. But in attempting to, in this very limited way, answer these questions, I'm going to do it, as I said, in a way that's personal because I don't know any other way to do it. And I'll start with giving you a little sense about where I come from, because in some ways, both maybe to myself and to some people who know me, I occupy a sort of paradoxical combination of experiences. And I hope that they'll be useful to you, not just for my own psychotherapy, but because they'll ring true to you in thinking about these problems yourselves. So on the one hand, I'm somebody who just loves big wilderness. Lots of people do, but I probably spent more time in it than many people. I've been very, very lucky. So for example, these are pictures of a trip that I took with some friends about just under a year ago. And we skied on North Baffin Island, 3 of us, for 3 weeks. And we were completely isolated from people. We didn't see anybody for those 3 weeks. We had no communication in or out. One amazing thing when you come out of a time like that, and this is for somebody like me who's obsessed with being in BlackBerry communication all the time, is you really don't know what you'll come back to. You know, has there been a new war? Or maybe one of your family is dead? You have no idea. And you inevitably slow down and think differently about the world around you and talk less and listen more on a long trip like that. An experience is very different in my experience from short trips, although I love those too. We didn't intend this to be about climate change. I just like these long trips, but you can't help thinking about that as well. As you go by these places, we have maps that are all based, as maps of Canada's north are, on air photos that are mostly taken from the 1950s, and so they show where the glaciers should be on the maps, and the glaciers are mostly all a kilometer or two back from where they were in the 50s, and that obviously makes you think. So on the other hand, I work on technologies that horrify a lot of people in the environmental community. I've been, over the last 20 years, one of the people most vocal in trying to get us to think seriously about these technologies that allow us to engineer the entire planet. I'll come back to them in a minute, but I've written papers about these engineering technologies, and I've worked on how to make high-altitude aircraft that would spray sulfur in the atmosphere to artificially cool the planet, and all sorts of crazy nonsense in that regard, and written opinions about how we should do it and govern it and so on. So this might seem like a bit of a paradox, and as I say, in some ways it does to me and to others. And in many ways, enough of my personal story for now, my objective in this talk is to try and push you folks, the audience, to think a little bit about what the limits are of thinking about our protection of nature in a way that's purely instrumental, purely about making it easier for us to live as 6 billion people on the planet and get all the good stuff we want. So I'd say that much environmental thinking, I suspect what you may have heard in the previous versions of these talks, is assumes the following things. It assumes that we are near these limits in some fundamental way. And I think it underplays the extent to which technology has made it easier to buy ourselves environmental protection. That's just a technology. And also the extent to which politically and socially we've actually got, in some ways, better at protecting the environment than we were over the last centuries. And I know that's not what one commonly hears, but I think you can make real arguments for that. So let me start with a kind of simple view of what I would say is the conventional standard environmental view nowadays, which is that we're stressed by resource shortages, so we're close to the limits of resources of, say, oil, the idea that the world's going to get a lot smaller, that we're going to run out of oil and run out of other resources in ways that fundamentally force us to change what we're doing, or maybe we'll run out of lithium for our batteries. The idea of environmental footprint, you look at this morning's New York Times, and Tom Friedman has an article saying that we're now using 1.5 Earths. There are various versions of this number floating out there. And there are also a series of views going back over the last half century that really make us think in catastrophic terms. And the use of the word tipping point, I think, reinforces that. One of the, I think, beautiful quotes, very powerful quote, that I helped set that way of thinking was from Paul Ehrlich about rivets. And I'll read the whole thing to you because I think while it's old, it shapes a lot of the way we now think. So Paul wrote, or Paul and Ann, I believe, as you walk into a terminal towards an airliner, you notice a man on a ladder busily prying rivets out of an aircraft wing. And somewhat concerned, you saunter over to this rivet popper and ask him just what the hell he's doing. He says, I work for the airline, Growth Mania International, the man informs you, and the airline has discovered that it can sell these rivets for $2 a piece. But how do you know you won't fatally weaken the wing while doing that, you ask? And the man says, don't worry. I'm certain the manufacturer has made the plane much stronger than it needs to be, so no harm's done. And besides, we've taken a lot of rivets from this wing already and nothing's happened. So then Paul concludes, all of us are passengers on a very large spacecraft, one on which we have no option but to fly, and it is frighteningly swarming with rivet poppers. So that's a very powerful environmental image, and specifically this was talking about biodiversity, the idea that it's not obvious what goes wrong when we make a species extinct, but that as we keep making species extinct, somehow the thing will fail catastrophically, that suddenly we'll lose the ability to keep feeding ourselves on the planet. That is the underlying message he's communicating. I care about species, I think, probably roughly as much as Paul does, but I don't believe there is data to support the view that when you lose species, things fail catastrophically. We've had lots of examples where we've lost a lot of species and ecosystems have changed. But the examples of really catastrophic change, the examples like that aircraft wing analogy where it really is true, you pull out one more rivet and the wing is just going to crunch off in seconds, or less than a second, I think don't capture very well the way the world actually works. So let me go through some of these in detail. First of all, starting with the question of whether we're going to run out of oil. So there I want to go back to another one of the kind of foundational diagrams. This is from M. King Hubbard in 1956, and this begat the entire peak oil industry. There are now people who believe we're going to run out of coal, people who are going to believe we're going to run out of all sorts of resources, and many of them build this around following the same methods that Hubbard used in these famous plots. So let's look at how well he did. So roughly, he made a prediction that looks like that, depending on which of these two curves you want to follow. It's not clear which he did, and this is what reality looks like for US oil production now. Let's see it with better data. So this is US oil production since 1900, and it really did peak in 1970. And the peak oil people always want to tell you that Hubbard was amazingly good because he got the peak right. Well, yeah, he did get the time of the peak right, but he got the amount of oil production at the peak completely wrong. And most importantly, he got the reduction after the peak completely wrong by factors of 3 or 4, depending on how you count it. This is true on all sorts of places you look. And I think we understand why it's true. There are dynamics in the oil industry that make it true. The bottom line is we have an absurd amount of hydrocarbons in the world, and our growing ability, technological ability to extract those hydrocarbons makes ever more of them available at prices we can afford, partly because the economy is growing very quickly. So from my point of view, the idea, I would love it as somebody concerned about climate, that we had a problem with running out of hydrocarbons. But I see essentially no serious evidence to support that view. It is true that we will run out of the remaining really easy oil in the Middle East, and it is true that that will have profound geopolitical consequences, but that's very different from running out of hydrocarbon fuel. So let's think about environmental limits. The graph on the top shows you the fraction of GDP that's used for agriculture. In the world now it's about 3%, and you can see the steady decline over time, and you've got Canada and the US there as well. In the US now it's under 1%. This gives us a lot of headroom in the following sense. So let's say that we want to be more environmental. Let's say we wanted to reshape global agriculture, doing more intensive agriculture, getting more crop out of a smaller amount of area, using fertilizers more carefully so we don't over-fertilize, being careful to do drip irrigation so we don't make soils so saline, maybe eating a little bit less meat, maybe using a little bit more genetic engineering, we might be able to feed all the people that we're feeding now with perhaps half, in any case substantially less land area than we do it now. That would dramatically reduce the biggest environmental footprint we have. This will all cost money, but this headroom, this fact that it's only costing us 1% now in the rich world, gives us the headroom to do that. Or, if we want to live, this isn't a forced choice, I'm just giving you options. If we want to live in a world that had 20 billion people, we could do it. Because again, with agriculture at only 1%, you could afford to do lots. Finally, if you wanted to adapt to climate change will no doubt have impacts that left unchecked will make it harder to grow crops. The higher peak temperatures will reduce crop productivity. Indeed, there's evidence that that's already happening. We've already lost 5% compared to baseline of crop productivity, according to David Lobel. But this fact that it's so cheap for us to grow agriculture in proportion to the total economy means that one thing we could do is afford to just spend more money on it, maybe a factor of 2 more money on it, and adapt to climate change as it goes. Of course, these are global averages. Of course, there are places in the world where much, much more of GDP is agriculture. But right now I'm addressing the question of humans' limits, how close we are to the natural limits. Not the other very important question about how humans decide to divide up the pie and how fantastically unequally they do that. I'll come back to that in a minute, but that's a separate question. People die of famines and will presumably continue dying of famines for reasons that are fundamentally say something about how humans organize themselves politically, about political dynamics, about fairness, about justice, but not about limits, I think. Energy, same. If you care about climate, as I do, the single thing you would do if you wanted to efficiently cut carbon emissions is you would get rid of coal-fired power. You would decarbonize the electric power system, which is roughly 40% of global emissions. And it's one of the places where it's easiest to make choices because you don't have to make a single choice. It's both cheaper, but you can also mix and match. You could do wind power in some places backed up by gas, or nuclear power in others, or central station solar in some. You've got a range of things you could do to decarbonize the electric power system. But now again, look at that number. Electric power in the US is now only 1.4%. This is the cost of generation, not including transmission. So if you want to replace that generation, you're only looking at something that's 1.4% of the economy. That means that you could, at least in principle, decide you wanted to double that cost over 20 years or so and decarbonize it, even triple it, without fundamentally changing our way of life. And yet there are people telling us that going to zero carbon would kind of reshape or limit our ability to operate as rich civilizations. Surely losing a couple percent of GDP. Remember, we spend several percent of GDP on the military. We spend, in the US, upwards of 15, I forget the number, on healthcare. So talking about things that cost a percent of GDP are things we could clearly afford. We are making a choice not to decarbonize because most of our fellow citizens cannot seem to get sufficiently concerned about doing it, but it is a choice. The fact that this stuff is so cheap gives us enormous headroom to make those choices. Now let's go back to the third of those points, which is, are things getting worse? So again, a standard part of what I would call the kind of conventional set of environmental myths is that humans used to live in harmony with nature. Humans used to live in some fundamental equilibrium that we have lost, that we've lost it in some way morally and physically. So I think this is by no means clear. It is certainly clear that ancient people saw the world in a very different way than we did. But whether they actually did a better job managing is very questionable. So here are the distributions of the size of mammals before and after humans got to places. And Australia is the most dramatic case. So what you have is the number of mammals on the x-axis and then their size in mass. So basically the black ones on the right are the really big guys. And in Australia, we wiped out, when humans got there 50,000 or so years ago, we wiped out like 80%-ish of all the mammals bigger than a kilo. They were really good eating, and we had really high technology for killing them. We tend to think of technology as just blackberries, but to me, the advanced technologies of bows and arrows and the other advanced hunting technologies were fantastically advanced technologies that were part of what he made humanity so different from pre-humans. And this has basically been true. You could tell the same story in New Zealand. It's been true almost everywhere that humans got to. North America would have been an amazing paradise. Humans moved down very, very quickly from north to south, and it would have been fantastic to move with them with all that easy hunting animals that weren't used to hunting pressure. You'll notice how many fewer died in Africa. That's because of coevolution, because the animals co-evolved with people. Air pollution is a big deal. I'm going to come back to air pollution again and again in this talk. But the idea that we have public problems that we need to regulate, that we need the power of a king to do the regulation, the idea that a local benefit pollutes and kills people nearby, these are not new problems. This is the first air pollution regulation of which I'm aware, and it's dated in 1307. So there was a problem. There were kilns in Southwark, south of London, and the kilns used to burn charcoal, but they switched to burning sea coal, which is high sulfur coal. And it emits a powerful and unbearable stench as it spreads throughout the neighborhood. And the air is polluted over a wide area, and the citizens and various other people don't like it, and so the king says, stop. Whether people actually did stop or not, I don't know. I'm going to guess not. But nevertheless, that was the beginning of regulation in London for coal-fired power. So these problems aren't new. Climate isn't either. It's tempting to think that we've only known about the climate problem for a few decades. But in fact, the first high-level report that went to a US president that had essentially all you need to know that you have a problem if you keep burning fossil fuels forever and putting the carbon into the biosphere, that report got to President Johnson's desk when I was 2 years old. And in many ways, it's better than IPCC because it's really short and simple. It links up the key facts you need to know. They knew about the CO2 in the atmosphere increasing, they knew about fossil fuel burning, and they knew basic atmospheric modeling, and they basically got the story right. I'll come back to this later, but they also thought about engineering solutions that then we didn't think about for a while. But that's not my main focus here. So coming back to this, I am not by any means claiming that none of these things matter. I'm claiming that they don't present us with catastrophes where our choices are forced. So I want to be careful. I don't want to claim that we don't have environmental problems. We have huge environmental problems, and I've spent most of my career working on them. Two more points to make on this. One is to celebrate the way we have succeeded. So in the rich world, we have made huge progress. on making the air cleaner, on getting DDT and long-lived organochlorines out of the environment, on solving the ozone layer problem, on removing heavy metals, lead and mercury from the environment. None of those were complete successes, and none of them were easy, but we made big progress on all of them. Interesting side point, on none of those did consumer choice play a major role. And so we should think again about how we conceive of progress on climate. I think if we do have progress on climate, it's because we make a collective decision in a democracy and regulate ourselves. That's the point of such regulation. Indeed, we now have a strange kind of ahistorical viewpoint. So when I talk to people who don't believe there's a climate problem, one argument I sometimes get is, oh, you scientists raised this concern about ozone and nothing happened, so you're just crying wolf again. Well, it's true the scientists raised the concern about ozone, and it's true the ozone layer didn't get destroyed. But of course, this is missing a key causal link. What happened was they raised the concern, and the concern got taken seriously by folks like Margaret Thatcher, actually, who helped to drive some of the key ozone regulations. And we essentially banned the polluting chemical worldwide in the most successful global environmental treaty of all time. And we are now well on the road to seeing the ozone layer rebound. So this was a clear example where we sounded the alarm and we fixed, to a substantial extent, fixed the problem. So there's another reason, though. When you go to speak truth to power, there are often ways in which we've constructed the debate so that all we can talk about is direct, costed environmental impacts and direct, quantifiable risks to people. Those things are important, but by limiting our debate to just that, we profoundly limit our ability to talk about things that really matter to us as humans. So imagine, if you will, some old respected scientist who has worked in the Amazon rainforest for her whole career, and she studied some little worm that lives in some little bug on top of some epiphyte. You can tell that I'm a son of a biologist, but I'm not really one myself. But let's assume you have such a person, and they go to testify in some hearing in Congress or where have you, and they're testifying to protect the rainforest in some decision-making capacity. Chances are, in most such things, this person will feel that they must speak about environmental carrying capacity or about the environmental services. We can calculate the value of the environmental services that come from that rainforest. Or they'll talk about the value of knowing about all those species because we might be able to invent new drugs from them. These are all perfectly valuable things, but they probably miss what the person's actually thinking. They probably actually just love the rainforest, and that's part of the reason they work there. And staking the argument that way changes the argument fundamentally. Because if you say my argument for preserving the rainforest is because I like its environmental services, that means you accept that if somebody else can build a machine that provides those services more cheaply, then you don't mind having it cut down. And I don't think that's what I think or what most of you think, but it is the way we mostly have constructed the debate in public. And we have therefore impoverished ourselves as a society in talking about what we really care about. So I could say the same thing a little bit about climate change. So I spend a great deal of time trying to convince policymakers to act on climate change. And I often make all sorts of arguments about how it's going to impact the food supply and so on. But those arguments, at least conventionally, and the way they are framed in the Intergovernmental Panel on Climate Change, the famous IPCC, are fundamentally mostly framed in economic terms. And so we essentially do what's called a cost-benefit calculation. We say, oh, the costs of climate change, of all the damages, all the sea level rise and all the crops, that cost, if we do nothing, is a few percent of GDP by 2100. And if we do something, that cost is less, but then we had to pay to decarbonize the economy. But if you do all the math, if we actually act, we'll be 1 or 2% cheaper than if we didn't act. So hold on. Does that mean that the reason I've worked on the climate problem for 20 years is to make my great-great-grandkids 4.8 times richer instead of maybe 4.7 or 6 times richer than they otherwise will be? If that sounded a bit cryptic, the point is we expect economic growth to go on, at least the standard economic view does. So we expect that people in 2100 will be really these kind of numbers I'm giving you, factors of 4 or 5 times richer than we are now per capita GDP. And so dealing with the climate problem as it's normally constructed means just making all these people 1% or 2% richer. This in no way captures, I think, what most of us are really caring about when we care about climate. So let me, it's a bit of a diversion, try and talk about some current problems that really worry me. I work on the climate problem, I care about it a lot, but if you ask me what really worries me in terms of impacts on my kids, direct impacts now, it's not climate. Or it's not climate for material reasons. And again, as I come back to in the end of the talk, I want to focus us on these non-material reasons, these non-utilitarian reasons why I think we do care about nature already, but we're afraid to say it and afraid to kind of stake our battle on those grounds. So what actually worries me? Well, it sort of goes back to the four horsemen. I mean, number one is war. Humans are fantastically effective at killing each other. They've evolved to do it for untold generations. This is an image of a nuclear weapon just a millisecond or so after explosion, and I find that kind of very pregnant, horrifying image. But I mean, as I assume you folks all know, there are submarines under the ocean right now today that can carry 192 independently targetable warheads, each of which is about 10 times bigger than Hiroshima. And at least during the Cold War, nobody knows for sure now, not publicly, they were actually technically able to be launched by the XO and the captain alone, because they weren't able to do what was called permissive action links very well to submarines. And there are only 400 or so cities that are bigger than 1 million people. So that really, those submarines are in a sense the ultimate weapon. They're the ultimate expression of creativity. Humans have been amazing for 10 millennia at figuring out how to increase our technology that allows us to do a better job of manipulating energy flows. And we've used that ability to manipulate energy flows better for all of human history for lots of things, one of which was war. So agriculture and the development of horses partly allowed us to have warfare on horses. And you can look at the way we did that partly as exquisite control of energy flows that were ultimately solar energy flows going into the food stocks that fed the horses. Václav Smil, who spoke earlier, does a beautiful job of explaining that way of thinking. So really, this is the penultimate vision. And this is, we all know, can be done very fast. This is a horrifying painting on the door of a missile silo that gives one a kind of realistic feeling of the fact that this can all be done in the time scale of this presentation. So let me talk to you about air pollution. So this is a real problem, and I'm going to drive it home because we are do such a bad job comparing the risks of different things. This is a risk we really know about, that is really real, that dwarfs all sorts of risks that get a lot of airtime, like whether or not cell phones are causing cancer. The bottom line, I'll explain the figure in a minute, is that basically, even in the rich world like here, 1% or so of all deaths are air pollution. My colleague Lester Lay was one of the first people to really prove this, but it was much better proved by this Harvard 6 cities mortality study. I'll show you this in one more slide, but the bottom line, if you look at this graph that you can't see up there, is that the unit of measure here is PM 2.5. Don't worry about that, but I'll show you a map of what it looks like in Toronto yesterday, 6 p.m. next, so you can make this a little more personal. But the bottom line is that you live a year or two shorter, if you live in an environment with, say, 10 or 20 ppm 10 or 20 more micrograms per cubic meter of these fine particulate matter. And you might think that maybe this mortality is just hurting old people, this is just making some old people die a little quicker, and that's certainly true, but that's not a reason not to worry about it, but it isn't. This shows it to you very clearly. So this is good year, bad year, good, or rather, bad year, good year, bad year. So the first plot shows you the actual amount of PM in Utah, and so there was a year, 85, 86, that had high particulate matter, high pollution, then a year with low pollution, then a year with high pollution. Look at what you see in bronchitis and pneumonia admissions to hospital. There is just no doubt. This is, at this point, just science. It's not speculation. And yet, we have a way of completely losing track of relative risks. So there are good arguments for nuclear power for and against, no question. But there's a way in which we just do a fantastically bad job comparing the risks of, say, the Fukushima accident or disaster, whatever you want to call it, to these risks that are just everyday. So Fukushima likely will kill by all the induced cancers that it's going to cause, as many people as 1 or 2 days of the people killed by the US coal-fired power fleet. So the US coal-fired power plants in their normal operation kill more than 10,000 people a year, this data. And Fukushima kills the equivalent of 1 or 2 days of that. And in the rich world, this dwarfs other environmentally caused sources of injury. Water pollution, rich world, tiny. Totally different story for the poorest billion who don't have sanitation, but rich world, tiny. Most of the other environmental toxins, tiny compared to air pollution. So again, this is my list of things I really worry about. And I think we've somehow got to sort of normalize out of existence. These are, in fact, the crucial things we really know how to fix. We absolutely know how to make progress on air pollution just by doing a better job putting scrubbers on our power plants and cars and so on. As I promised, I made this a little more personal. Those numbers there are the numbers for 6 p.m. yesterday, and those are in the same units, so the numbers bigger than 15 are starting to be numbers that knock off more than a year of your life. I picked 6 p.m. because it's a little worse than. That's not the same as the average. You guys can go freely look at that yourselves. Of course, my next concern is obvious, is poverty. It's not something I work on so much, but if you think about moral choices that we're making and where we spend our money, you have to think about it. And when you think about climate, you have to be able to deal with the question of why should I spend money on climate now, which is protecting my great-great-grandkids, when we're not spending very much to protect people living today. There are roughly 2 billion people living on less than $2 a day. There are roughly that number who don't have basic sanitation, don't have latrines to go to the bathroom in, don't have access to basic clean water to drink. There are 5 million people, roughly, mostly children, who die from malnutrition, and roughly an equivalent number that die from waterborne diseases. So these represent a kind of moral gap between us and them, given the ratios of income. There's no more nice way to put it. So now I want to return to some of the stuff I work on day to day, to these ideas about engineering the planet. But as you see, those will bring up the same questions that I've dealt with before, which are the questions of why? What's the goal? Are we engineering the planet to reduce the impacts on humans or to leave more of nature the way it is? And I'm mostly a technocrat and an engineer. I can engineer the planet lots of ways, but I have no better values than anybody else. I cannot tell you any more than anybody else can what are the right reasons to be doing it. But I think we need to confront more clearly that we need that conversation about values or we are just not making sense. So let me give you a kind of roundabout way to think about the whole climate problem and give you some words. So these are the sort of cycle of life, if you like, for climate. You can write a similar one of these for other things like air pollution. And so there are various ways in which we can intervene to solve this problem. The first one is conservation, which in the technical worlds of people who do energy studies doesn't mean more efficiency. Conservation means actually living with less. And there's nothing so bad about living with less because there's a lot of evidence that living with more in the rich world doesn't bring us much more happiness. We're saturated for stuff. Then there's efficiency, which means living with the same amount but using less inputs to get it. Then there's low carbon energy, which means wind power, solar power, nuclear, what have you. Then there's this stuff which I also work on a startup, so warning about self-interest, that you can in principle remove CO2 from the air by many methods, among them the one that I work on afterwards. But it's important already to think of the moral aspects. So the student of mine who first worked on the technology long before he had a startup company for taking CO2 out of the air, he fretted about the fact, and I do too, that he was making the world safe for SUVs. Because it is a technical fix. And technical fixes allow us to consume more, if that's what we want to do with them. Or this thing that I'm now going to come to, solar radiation management, which is basically this idea that we can cool the planet by putting pollution, basically, reflective particles in the upper atmosphere, and those reflective particles will reflect away some sunlight and so partially compensate for the climate change that comes from CO2. Finally, we can adapt. People will adapt automatically. Of course, polar bears don't adapt in the same way. So I'm going to go through these next slides relatively quickly, but I should say there are these two totally different kinds of things that are called geoengineering. I think that word is in many ways very appropriate because we are talking about engineering, which is the deliberate application of science to control nature for human ends. That's more or less the definition that one sees in many dictionaries. That's what we're talking about doing to the planet as a whole. And there are two kind of classes of things. One is this idea of blocking out radiation, the other removing CO2. And I'll just say a few words about this. First of all, there is no doubt of the basic ability to do this and do it at very low cost. There are lots of doubts about what the side effects are. There are enormous doubts about the wisdom of it. There are doubts about how it interacts with human societies politically. I'll get to some of those in a minute. But we know that big volcanoes put sulfur in the stratosphere. We can observe it. And the Earth gets cooler very quickly after a big volcano. And we've observed this many times, and we understand the physics of it pretty well. So there's little doubt that if we wanted to, we could put the same kind of sulfur in the stratosphere, and we would have already tested some of the environmental impacts since volcanoes had done it, and we would make the Earth cooler. So if you warm the Earth up with CO2, you could cool it back down to some given level by putting more reflective particles in the atmosphere. There are things you could do that might be better than sulfur, but the basic feasibility is there. And it is absurdly cheap to do for reasons that have to do with sort of basic science and engineering. But cheapness doesn't necessarily mean we should do it. It's also absurdly cheap to make nuclear weapons on the scale of the overall costs of warfare, but that doesn't make them a good thing. So here are some guesses about how research on solar geoengineering will come out. Some of my colleagues would read this slide and get frustrated and say I was leaping to conclusions, and I freely admit that in this case I am. But I've worked on this for a long time, and these are my guesses. The first thing to say is a caveat. There's been a taboo against research on this topic, and the taboo has everything to do with some issues of moral hazard that I'll come to in a minute. That taboo is going away now, but there has been, so there basically has been no serious research. So everything I'm going to say is kind of speculation. But I think we can say the following. Each of them have a long caveats that I could write a lot of papers about, but I won't bore you. That you could test this. It's not all or nothing. It's likely that this technique, this idea of shielding away some sunlight, would enable a considerable degree, you can't hold me to exactly what that means, a protection against the risks of a lot of the things we worry about for CO2-driven climate change, like damage to crop systems, melting of major ice caps, increase in extreme weather events, or rapid warming of the Arctic and retreat of sea ice. So all those big things. The compensation is fundamentally imperfect. So if you think that now that you have this magic thing, you can just keep putting CO2 in the air forever, and at the same time keep adding more of these reflective particles to the air, you could do that, but you will not have the same world. You will move farther and farther away from the current world, and eventually you'll see catastrophic climate change anyway. But you could buy yourself a lot of protection pretty cheaply, we think. So what are my fears about this technology? I'll go through them. The obvious fear, of course, is the risks, but that's not my main fear. My first and foremost fear comes back to the fact that humans are very good at having wars. So this technology is very fast acting. There's huge leverage, so it's very cheap to do. So essentially any country in the world could potentially do it. Its effects are unequal. And I think those things together in the unstable world we live in could well increase the likelihood of conflict. You can easily imagine scenarios in which one country, say China, wants the climate one way, and another country, say India, wants it another way. These are nuclear-armed states. We do not have a governance system right now in place that allows us to make these decisions about basically how to set the global thermostat. So my biggest fears are not about the technology itself, the narrow technical part, but they're about the way the technical part interacts with the reality of humans and their decision-making. Then there's all the side effects, ozone loss, blah, blah, blah. I take these seriously. I work on them professionally, but my guess is that they are not going to be the dominant drivers. Then there's this sort of easy-out moral hazard problem, and I have a simple cartoon that illustrates that far better than any academic paper. I'll read this all because you can't see some of the bottom of this. It says, the year is 2060, the search for a breakthrough technology to solve climate change continues, and one of the geeks says, it's a time machine we hope will take us back 50 years to when we should have put a price on carbon. And then one of the guys at the bottom says, we'd better hurry. And the other one, they always have the punchline with the smallest little guy in these cartoons, says, no, there's no rush. That's the point of a time machine. And I think it's exactly that that scares us, that makes us realize that these technologies that promise a fix a long time in the future get us out of the need to actually act now. So that's what is often called the moral hazard problem. And in a sense, these technologies are partly a time machine. If you think of time marching forward as the amount of CO2 in the atmosphere grows, if we can take CO2 out of the atmosphere, we're in a way then moving back in geological time, moving out of what's become called the Anthropocene, the geological era in which humans shape what happens. But the last risk, and the one that I really want to finish on, is this business about really accelerating the end of nature. I think Bill McKibben had it exactly right in that book about the end of nature, that if we come to have the whole climate be something that we have made a political decision about, it is then an artifact. An artifact in the following sense. When you go and look at this table or this chair, and you wonder why it looks the way it looks, what it's made out of, you think about human design. That's what engineered systems are. When you look at a leaf on a tree in some distant place, and you ask why it is the way it is, assuming you're a biologist, you think about evolutionary history. That's the explanation for how it got there. As more and more of the world comes to be decided by humans, the question of why the climate is the way it is, why the weather is what it is today in a world that's engineered, is really a question about human design. And so in that sense, it's quite right to call it an artificial world. Myself and others, I think, who are working on these technologies of climate engineering are mostly thinking about it as a way to limit environmental impacts. But once you've invented a tool, people may use the tool for things very different from what the inventors originally wanted. And there really is my core fear and the core of what I want to give this talk about, that focuses on the necessity to speak clearly about choices and values here. So if you've invented this technology, you could use it for lots of things. So one of the beautiful versions of this was given in a 1992 National Academy study by Tom Schelling, and he said, interest in CO2 may generate or reinforce a lasting interest in national or international means of climate and weather modification, and once generated, that interest may flourish, independent of whatever is done about CO2. So let me try and sort of pick that up and frighten you a little bit. So right now, I've been working on these technologies as a means to reduce the rate of change of the sort of standard climate impacts. But lots of people think that the main thing we should be doing is maximizing the ability of people to feed themselves. Perfectly reasonable thing to do. If you hired me and a team of people as climate engineers and said our job was to maximize the carrying capacity of the planet, would we bring it back to pre-industrial? I don't think so. If you hired us, likely, we haven't been hired for this, and it's not a contract I would take, but if we were hired, very likely you would find the world has a bigger carrying capacity, you can grow more crops. If you make a world with higher CO2, and then you dial down the sun a little bit so you don't warm it up too much, and you reduce the pole to equator temperature gradients. All those are things we could potentially do. And at this point, I'm not just talking to my hat. I think I said the same thing a year or two ago, but at this point we've actually run the cutting edge crop models and run them in worlds that are geoengineered according to climate models. And those models do show higher productivity in those conditions. That is not a reason to do it, but is a reason for us to be very careful about what we wish for. And to understand that if we are not clear about the reasons for why we're doing things, if we just turn the technocrats loose without thinking about what the goals are, we may get answers that are really different than the ones we expect. So let me sort of go back to the stuff I said before. Why should we preserve nature? Are we at the limits of global carrying capacity? If so, it's easy. We don't have to worry about morals. If this is really a forced choice, we either reform our ways or die, which is what a lot of the environmental community wants to say, then it's easy. Or has our technology given us so much maneuvering room, so much leverage, that we have lots of choices about how we want to shape the natural world? I think it's really important to re-emphasize the kind of moral emptiness that goes hand in hand with a kind of catastrophist vision. If it's really just about ecosystem carrying capacity, if it's really just about human survival, not that those are not important things, then that says, as I say, if you invent a machine that's a substitute, then that's fine. Again, if you stake your protection of the rainforest on the fact that it's producing drugs that may be useful, and then you find that it's easier to produce those drugs by just direct, in the lab work, then you've lost your reason to protect the rainforest. Same for climate change. If our argument on climate change is ultimately just material, and I don't think it is, then you've got to accept that if a technology comes along that produces a cheaper technical fix, that you should embrace it. If the only metrics that matter are metrics about just direct human risk and economic power, and those are the metrics that we mostly frame this debate around, the IPCC frames the debate around, then if you invent a way to engineer the system to allow you to get those things in a way that walks you farther from the natural background, you better be prepared to accept the result. And if you don't want to accept that result, you have to think hard about why. One of the nicest papers that shaped my thinking about this is by Lawrence Tribe, who was a famous jurist who worked on Supreme Court jurisprudence. I believe he worked on the Nixon impeachment, among other things. But this isn't about the Nixon impeachment. He wrote this great article in the early 70s called Ways Not to Think About Plastic Trees. And the article picks up the following line. I guess that they were replacing some trees that didn't grow very well down the freeways of Los Angeles with plastic trees because they were cheaper and they would stay there in the bad air quality they had in Los Angeles. It's got better because we regulated, we made collective choices. And Tribe got to thinking about the fact that he liked real trees, but that maybe that's because he just grew up with real trees, and that maybe people who grew up in an environment with plastic trees would be perfectly happy with plastic trees. And I think one of the ways that we lose this debate, or one crucial fact that gets lost in the debate about climate, is we assume that values stay the same, that they're independent of choices. So we say, oh, we got our values, and we got choices about how much we invest in clean energy, but there's a feedback. Our choices about what we do will change our values and the values of our descendants. So if we decide to live in a world of plastic trees, probably our kids will be fine with plastic trees. Maybe the opposite. Maybe they'll come to hate us for getting rid of the real trees. But in any case, their values probably depend on our choices in ways that are pretty important. So a world in which we decide collectively that we are going to suffer a little tiny less ability to consume in exchange for being able to protect some of the natural character of the world, if we can make that collective decision, that probably influences our values in ways that are unpredictable about how we think about the relationship with nature in a way that clearly has to be different. Nature is not this wall of frightening nature that it was to people coming across this continent 400 years ago. We are basically in the gardening business with this planet, like it or not. As one of my mentors, Bill Clark, said, we have to decide if we're going to be sloppy gardeners or good gardeners. We have to decide if we want a more wild garden, but we can't pretend that we don't have the power to do this. So let me try in the end to say a little bit about why nature might matter. Oops, I'm going to go back and forth here. It's a bit airy-fairy, but let me give it a shot. As we fly around in airplanes, as we live in tall buildings and we flirt by texting and all this strange stuff we do in the modern world, we can materially live without nature quite well, I think. We could free ourselves from nature as a physical necessity. We could live underground in nuclear-powered burrows with artificial air and food that we grew in vats. There's nothing physically impossible about any of this, and it's not obvious that we'd be less happy doing it. But it is important to say that our visual system, our emotions, the things that make us angry and sad, the things that make us love things, hate things, these were all shaped by millions of years of fiercely competitive evolution in which we competed with each other and in the natural world around us. And that natural world has shaped us in our brains in ways that is fundamental. That doesn't mean we can't change that too. I'll come to that in a minute. But as of now, our brains are shaped that way, even though we live in artificial environments like the one we stand in right now. And that shapes our responses to the world around us in ways that are fundamental. So I think there are some reasons why people get resonance in nature that aren't material at all, that have to do with stuff that is in our heads. E.O. Wilson has called this biophilia. Other academics don't seem to buy it in a professional sense, but I think he has picked up something that is profound and real. Now, to be clear, we could change this too. We could re-engineer ourselves. We could re-engineer ourselves genetically. Human germline engineering, I think, is likely going to come. We could imagine in some ways melding our brains to computers. I don't regard these things as inherently good or bad. So I just want to say that we could change the basic kind of programming infrastructure, if you like, of us. But at present, we've got what we've got genetically. There's amazing studies, so-called matched twin studies, that show you that roughly half of the variance, half of what determines who we are, on almost anything you care to mention, even political affiliation, turns out to be genetic. So the idea that we're kind of blank slates and that we're just a product of evolution is a fantasy. We're genetic in deep ways. The very way color vision works is adapted to where we lived, which wasn't buildings like this. So my view is that the natural world still serves as a psychological and moral anchor, even though less and less of us spend any time in it, and that has a real value. I'm not saying it's more valuable than anything else, but it has a real value. And I'm not claiming this anchor is absolutely necessary to our survival, but I am claiming that if we can protect that anchor substantially for a few % of GDP, we would just be insane not to do it. Insane not to pass along to our great-grandkids the option to have that natural world. And that this has nothing to do with the direct economic value of that world. Thank you.
Thank you, David. Yours is a very compelling perspective, and I'm sure there are a number of you in the audience here today who have questions. I just want to remind you to grab the attention of Rebecca or John, and they'll hand you the microphone. Please keep your questions concise as possible, just so we can field as many as possible. So, right here.
David, a little too loud. Anyway, this is some data that I picked up about 2 years ago, 3 years ago, and it was supported by some new data some years that global warming was progressing at a faster rate than the worst scenario. Your group at that time proposed a quick fix to slow the climate change, to cool the Earth. You're going to do this overnight. This was where your attitude was to shoot in small disks, size of a donut, with 100,000 planes, etc. What happened? I mean, this, to me, it sort of gave me the impression it was almost like a great big, humongous refrigerator.
So I'll answer two parts. First of all, the Arctic is melting much faster than people expected. It's not clear that the overall warming is, I think the warming is within the range of models. I wouldn't say that it's faster than expected. If anything, maybe the opposite in the last decade. I'm be very careful about what I am doing in work on geoengineering. I do not believe any of these technologies are ready for implementation. I believe it makes sense to study them. So I have spent some time trying to push against what was effectively a taboo of the scientific community that said we shouldn't even think about these things. And the reason people felt that was sensible, and maybe I'll ultimately think that I was wrong to have pushed people to talk about them. The idea was that if we talked about them, then people would lose their incentive to cut emissions. And so it was a bit like the Southern Baptists who had a view that we should not talk about birth control because if we did, then people would just have more teenage sex. And I think that two things. One is I think that our duty as scientists is to tell what we know, all what we know. Fundamental duty. It's not our job to try and only tell part of what we know because we think it'll protect people. Einstein said this beautifully in a quote, which is carved in the U.S. National Academy building or on his statue outside. I can't remember the exact quote, but effectively says, those who have the privilege, and I do have a wonderful privilege, paid for by taxpayers to be a professor, those who have the privilege to seek for knowledge have the responsibility, the duty, I think he said, to tell all that they've learned. So that was one aspect, because I think we just have to say. But let me be clear, I am not proposing personally that we have fleets of aircraft up tomorrow. In fact, I would happily work to prevent anybody who did want to do that. I'm proposing that we have research programs that look at it and that we begin to think hard about how we govern it.
There's a question up here.
Yes, David. The idea that ultimately this is a moral question is very good, and ultimately is a question about choice and how we deal with the fact that technology gives us choices about how we plan the climate, how we interact with the climate. But how do you see the world, supposing that you are listened to, supposing that the problem is solved along the lines that you would most like, what does the world look like for our grandchildren?
Maybe I'll try that. I mean, the obvious answer is I have no idea, of course. But let me try two things. One is that I made it sound like it's individual choice. But if I asked any 1,000 people in the world if they liked war, I'm assuming essentially none would say yes. And yet we still have wars. And that tells us something about the difference between our individual preferences and the outcomes from our political system. And this isn't some, cheap shot against individual politicians. It's just about the difficulty of humans organizing themselves so the outcome reflects what we want. I think you can make an argument, and I think this is important, that Western democracies have in some ways been incredibly successful in giving people enormous opportunities for consumption and in lots of ways giving people amazing personal freedom. But Western democracies have made it very difficult to do anything that's not about consumption in some form. Very difficult for us to spend any substantial amount of money on some big vision, whether it's protecting our great-great-grandkids from climate change or what have you. More centralized, you might say, undemocratic societies were able to do that. So if you think about the communities in Europe where great cathedrals were built, those cathedrals were built over hundreds of years. And I am not an expert, but my understanding is that in some cases, several % of GDP of those communities would have been spent in building those cathedrals on timescales of like 100 years. Now, you could argue that wasn't necessarily a good thing, right? These were serfs. There was somebody in charge. It wasn't democratic. So I'm not suggesting we go back to something so undemocratic, but I do think that our democracies are seemingly unable, and maybe need some reform at their root, to allow us to make any big collective decisions, of which climate is just one example. And so part of my answer is that if we get to a place where we've really solved this problem, we'll have changed some of the architecture of industrial democracies about the way we make decisions. I don't know how to do it, but I think we have to do it if we're going to make progress. This is not fundamentally a technical problem. Now, the other question, other side of, I guess what you're asking is, what does it actually look like? If I had to guess, my guess is that people will be pretty slow at restraining carbon emissions. And that's just sort of, you might say a guess from inertia, because we've been slow for a long time. We could have started regulating climate emissions seriously in the 1970s, but we didn't. My generation, I often talk to school kids, has sort of utterly failed to make progress on this topic, so it's really the next generation that will have to do it. I think it's important for us not to get lost and say we can't do it. It's popular to sort of say, well, we just can't cut emissions. Obviously, we can cut emissions easily, but it's a choice. But as of right now, I'd have to guess that people won't restrain emissions very much, and we will end up doing some of this engineering. That is not advocacy. I would prefer the opposite.
And over here?
I've often heard that only economists and cancer cells believe in exponential growth. And you've made a very powerful argument about the role of technology in providing headroom on a whole series of issues that we confront going forward. But in the lifetime of my brand new grandchildren, with a 3% compounded annual growth in the economy, that's 16 times between now and 100 years from today. So is there enough headroom possible to see that sort of endless economic growth being accommodated without starting to hit some of the natural barriers that you dismissed by saying that we did have this capacity?
I don't know. I mean, that's got to be the honest answer. But I suspect that the physical limits are very far away. So I think the bottom line is I do think we can be tens of times richer. There's a beautiful book, which I'd recommend on this, by a demographer called How Many People Can the Earth Support? By Paul, I forget his last name, excuse me. And what's beautiful about it is it goes through hundreds of years of different people's calculations of the Earth's carrying capacity. And it shows how those calculations ultimately tell us more about the kind of social framing of the problem at the time than they tell us anything about the real carrying capacity of the planet. I think I have no trouble imagining worlds that have 100 billion people on them and don't collapse. We know how to make energy with extreme, we know how to make extraordinary amounts of energy, and with energy you can do all sorts of things. You can make food very compactly, you can desalinate seawater, etc. Let me just pick up that one. There's been extraordinary progress just in the last decade and a half on the price of desalinating seawater. So we can now build large facilities that will desalinate water at about $1 a cubic meter. And in big cities like this, $1 a cubic meter is sort of the total use of people. So that says that suddenly, in a world where we have energy, and there are plenty of ways we can make energy without carbon emissions, we're substantially freed from the natural water cycle for at least part of what we need, not for agriculture. So the bottom line is, I don't know, but I don't see hard physical limits. I see more social limits. I wonder whether a world that's big can avoid a war. And I see choices about how we manage the environment, but I don't see hard limits.
Any more questions? Yes, right here. Rebecca?
Hi, thanks for your talk. So you were sort of downplaying, I guess, the role of engineers and scientists in affecting a great deal of change, because you put a lot of the emphasis on society sort of identifying its values and social barriers as opposed to physical ones that are going to impede our progress. So I guess part of your vision for what a scientist should be is to do research and communicate all of what you find to the public. But I think you're also doing a few other things. Like, for example, you're here right now talking to all of us, and you are running a startup company, I understand. Yeah. So is there a role, I guess, for scientists in participating in the debate where a society has to identify its values, or are there other things that you think that scientists should be doing?
Of course. Human beings have lots of roles at once. I'm also a father. So there are lots of individual roles. We don't do a single thing. But I do think very differently about my role, for example, as a father, or as somebody running a startup company, or as a scientist. So I'd say I'm speaking to you as a concerned citizen or public intellectual, whatever you want to say, but I'm not primarily giving a scientific talk today. But when I do science, I believe that this value of saying all you found unequivocally is crucial to what makes science work. And that's different from the role of a startup company. Startup company, we don't tell people what we're doing. We just try and make it work. Completely different set of values. And I don't think they're incompatible, they're just different. So do I think scientists can be involved in making the world a better place socially? Of course. Some of the people who were my mentors were some of the people involved in the creation of atomic weapons and in their regulation. People like Phil Morrison, who did an incredible job, and others getting people to think hard about how to manage a world with nuclear weapons that didn't have a war. Part of the reason that we didn't have a hot war was not because the politicians figured it all out, because a lot of scientists spent enormous energy and sort of moral vision thinking about how we could live stably with the Soviets and not have a shooting war. So I absolutely think it's our duty to do that as scientists, but I think we have to be careful in assuming that just because we know more about a topic, that our values count any more than anybody else's values.
And over here.
Okay. Hi there. You talked earlier about how we assign values to things like rainforests and how we completely miss the point when we, use pharmaceutical projections or whatever else, revenue models. So how can, I guess, within the context of the legal system, can, we kind of hit the point, I guess, or stop, using these numbers that really don't reflect what we mean?
So, first of all, when you give a talk like this, and this is the first time I've given this talk, you have to find a way in a public talk to make a sharp point. So I am not saying that we should ignore all the actual values that come from rainforests. There are lots of them. And in thinking about how to manage rainforests with local communities, of course we need to think about all the ways in which we get local employment and all. I'm not in any way trying to make that unimportant. I'm trying to say that we shouldn't shape that as the only thing. We should avoid letting ourselves get caught in a way that excludes the larger conversation about values from the discussion. As to how to do it, I think the honest answer is I have no idea. I certainly have no idea about the specific legal ways to do it. I think this gets to the issues about reforms. I'm not talking about anything that radical, to how we make decisions in Western democracies. Because I think these conversations, this issue I'm raising for climate, I think comes up many other places in our society. If you think about the decisions we make around healthcare or education, there are also places where we have purely technocratic discussions and somehow don't have discussions about some of the value trade-offs. And so I think that's intrinsic to the way we built our political systems. This isn't blaming one party or another, it transcends party, but I think we need to reform them.
There's a question over here.
Yeah, hi, Kathy McClellan. Are you, at your gut level, ultimately optimistic or pessimistic about many of the things you brought forward today?
Ha! That's the final question on the exam, eh? I am very optimistic about the pace of continued human technical evolution. So I really do think that we've got a kind of technological frontier that goes forever. I am very worried about our ability to get through the next century or two without a big war. I think that the fundamental fact that some people sitting at Los Alamos realized is that you cannot have nation states with nuclear weapons. You can't. We've had them for a while, but the whole idea of a nation state, as it was conceived by Europeans, was that you settle disputes by war. And it worked fine. You killed 1 or 2% of the population, it wasn't a big deal. We had wars for centuries. It was a worked out system. Might not have been the best system, but it was a system. We cannot settle disputes that way anymore, period. And so far, we've managed to avoid it. But I think we are going to have to make a transition to something that really removes the power of nation states. And in some ways, that's happening. We have all these transnational institutions which have power, from corporations to United Nations to standards bodies, what have you. So it's not like any single moment where the black helicopters come down. But I don't think, excuse me, I don't think the rest of this transition is necessarily, the potential for error is very real. So that worries me a lot. And I worry personally that we will lose a lot of the natural character of the planet. And I don't regard that as a sort of species-threatening thing. I just regard this as fantastically sad when we could preserve it so easily.
And ladies and gentlemen, I think that concludes our talk for today. Please join me in thanking Dr. Keith one last time.
Thank you.
Please watch for the agenda in a few hours. For now on TVO and WGSI.org. And if you are interested in purchasing books, Wordsworth Books does have a table out in the atrium that you can visit. Thanks again.